In this video, we will study multiple linear regression. In the previous video, we have studied about simple linear regression. If there is only one independent variable, then the linear regression is called as simple linear regression. We have seen this in the previous video. If there are more than one independent variables, then the linear regression is called as multiple linear regression. Okay, like this one. Let us say this is feature 1, this is feature 2, and based on these two features, this is our predicted value. Okay, so here we are having more than one independent variable. This is one independent variable, this is the other independent variable. So based on these two values, we'll predict the value of y. Okay, so this is an example of multiple linear regression. I hope this is clear. Now, in the previous video, we have seen the formula of simple linear regression. Okay, and we also learned what each and every term means. This was the data set, right? And this was our graph. Now, what about multiple linear regression? See, this is the formula of multiple linear regression. Okay, y equal to b0 plus b1 x1 plus b2 x2 plus b3 x3 and so on up to bn xn. Okay, if you are having n number of features. So what is this now? x1, x2 and so on are the values of the independent variables. Okay, and y is the value of the dependent variable. Based on these values of x1, x2, x3 and so on, will predict the value of y. Okay, hence this x values are independent variables and this y value is the dependent variable. Okay, and what is this b0? b0 is a constant. Okay, y-intercept, and this b1, b2 and so on are the regression coefficients. Okay, these are actually the weights. Okay, like see, let us go through an example. Here we have a data set, age, sex, body mass index. Okay, age, sex, body mass index, children, smoker, region and charges. Okay, so basically this data set describes the individual's medical cost, okay, over a period of time. Like for example, now let us go through the first record. Person's age is 19 and the person is female, body mass index is 27.9 and that person has no children and the person is a smoker. Yes, a smoker, and that person is from southwest region. Okay, so what are the medical costs over a period of time? 16,884.92. Okay, so here what we are going to do is, based on this age, sex, BMI, children, smoker and region, will predict the charges. So here this age will be x1, this will be x2, this will be x3, this will be x4, x5 and x6. So we have 6 independent features, right? 6 independent variables. Based on these 6 independent variables, we are going to predict the charges. So this will be our y value. Okay, this will be our y value. I hope this is clear. And what does a simple linear regression do? Simple linear regression model will draw a line. Okay, see, these are our x values, these are our x values, these are our y values, right? Okay, so these points are our data points. So simple linear regression will draw a straight line which best fits this data, right? Whereas multiple linear regression, if we are having two independent variables, that is x1 and x2, see this is x1, this is x2, based on this x1, x2 will predict the value of y. So here we have two independent variables. So based on these two independent variables, we are going to predict the value of y. So in this case, when we have two independent variables, our multiple linear regression model will draw a plane. It will not draw a straight line, it will draw a plane. Okay. So this is a plane. Alright. Now, if we have more than two features, okay, more than two independent features, let us say we have three, like x1, x2, x3, these are the independent features, and based on these values we'll predict the value of y. Okay, in that case a model will draw a hyperplane. Hyperplane will look like this. Okay, this curve. Okay, I hope this is clear. Let us go to the code. Let us go to Jupyter notebook and write the code. Let me clear the screen. All right. So first thing, okay. Now let us name the data frame as df. What we are going to do is we are importing the database read underscore CSV. Okay, the database name is insurance, the file name is insurance, and the extension is CSV. Okay, so we have imported the database and it is stored in df. So let me just print that. So this is our database. Okay, so what do we have here? We have age, okay, the same database which we saw in the PPT, age, sex, BMI, children, smoker, region, and the medical charges. Okay, so we have 1338 rows and 7 columns. All right. Now, see, we have a problem in this data set. See, age is 19, it is a number, sex is female or male, right? Here, this sex column is categorical, and this body mass index BMI is a number again, children is a number again, smoker is yes, no. This is again a categorical data, right? And region is again a categorical data, southwest, northwest, northeast, okay, southeast, and so on. So this categorical data is not good for machine learning because machine will understand only the numbers. Okay, so what we need to do is we need to convert this categorical data, this sex, smoker, and region into numbers. Okay, so we need to convert this categorical data into numbers. So let us first go ahead and change the values of sex as numbers. So df is the name of the data set. We are going to change sex. So I wrote that column name here, df sex, df sex dot as type. We are changing the type of that to category. Okay, so df sex is equal to df sex dot category, that is cat, and we are giving some codes to that. Okay, so what we'll do is we'll also print this value. Okay, as you can see here, see sex was female and male, right? So we got 0 for female and 1 for male. So this categorical data changed into numbers now, right? Let us go ahead and do the same thing for smoker and region. Okay. For smoker, right? So let me write smoker here. Smoker here. Okay, so see here, smoker also changed, right? Smoker 1 0. So for yes we got 1, for no we got 0. Okay, let us do the same thing with region. But before that, let us see how many regions we have, right? So df region, region, okay, dot unique. So this will give us the unique values in the region. So we have southwest, southeast, northwest and northeast. Okay, so we have 4 types, right? Let us go ahead and convert that categorical data in region into numbers again, right? So region here, region here, region. Now let us see if we are having any null values or not in our data frame. df dot is null. Okay, let us see how many. Let us add everything and check. So we don't have any null values. All right, okay, we are good to go now, right? Okay, now what we'll do is we'll take the values of x and y. All right, now what are these values of x and y? See, 1 second. See here, all these values are x values, right? This one, this will be our x1, this will be our x2, this will be x3, x4, x5 and this will be x6 and this will be the value of y. So what are we going to do now is we'll store all these columns 1 2 3 4 5 6 columns in capital X and this y values in small y. Okay, we are splitting this data frame into 2, x and y. Okay, let us go ahead and do that. Okay, so capital X for us will be equal to df dot, we are going to drop the last capital X is equal to df dot, we will drop the last column. The last column was actually charges, right? So which columns are we going to drop? We are going to drop charges and save the rest in the value of X. So let us go ahead and print this. See, age, sex, BMI, children, smoker and region is now stored in X. We don't have charges here. Okay. Now let us save the values of charges in Y. So Y equal to df charges. Okay, and let us see the values of y. So these are the values of y stored in, so these are the values stored in y. All right, okay, now we'll split our data set into training and testing. Okay, we are going to build a model now. Before that, we are going to split our data set. Okay, so from 1 second, from sklearn dot model underscore selection, import train test split. Okay, and x underscore train comma x underscore test comma y train comma y test equal to this train test split method will take the value of x and y. Okay, let us give the test size as well. Test size is equal to 20%, so 20% is 0.2, and random state, let us take that as 0. Okay, in simple linear regression we have seen what test size is and what random state means, right? Okay, so I'll go ahead and execute this. So there is a syntax error, x train x test, y train y test. Okay, I did not give comma here. Okay, now from sklearn dot linear underscore model we will import linear regression. We'll import linear regression. Okay, and let us initialize that and let us store that in LR, linear regression. Okay, let us print LR as well. Okay, now we'll fit the values of x train and y train for our linear regression model. Okay, so for that LR dot fit x underscore train comma y underscore train. Okay, all right, now we'll predict the values and store that in ypred. Ypred is equal to LR dot predict. This predict model will predict the values based on our x test values, right? So it has predicted the values. Let us go ahead and print the values, predicted values. So we have y underscore pred. Okay, so these are the predicted values. Now don't get scared by saying these numbers. See, very easy. This I'll explain you about the first number. This first number is 1.101722305 multiplied by 10 power 4, 10 power plus 4. Okay, which means this is 1117.2305. So this is the first predicted value. Okay, it is like that. Now let us go ahead and print predicted values and the actual values side by side, and let us print the difference also. Okay, let us print the difference also so that it will be clearly understood by us. Okay, so what I'll do is I'll write actual and predicted data frame, that is df. This is just a variable name, you can give anything you like. pd dot data frame. Okay, in that let us give the first column name as actual. These are the charges, right? Actual charges. Okay, and what are the actual charges? Y test. Okay, comma, these are the actual charges, right? The next one, predicted charges. Predicted charges. Predicted charges are what? Y underscore pred, right? Let us go ahead and find difference also, difference of actual and predicted values. So this is y test, okay, minus y underscore pred. Okay, let us go ahead and execute this. Great, so I'll just copy this and paste here. Okay, so see here, these are the actual values, these are our values, and these are the values predicted by our model, and this much is the difference. Okay, I hope this is clear. Now what we'll do is we'll go ahead and find the values of intercept and the coefficients predicted by our model, given by our model. So it is LR dot intercept underscore. So this is B naught, right? We'll execute that, and it is minus 1100 661. Okay. And now the coefficients, LR dot coef, that is coefficient. So we had 6 variables, right? Independent variables. So we got 6 numbers, 1 2 3 4 5 and 6. Okay. Now let us go ahead and predict, give some values. Okay. LR dot predict. Okay, we need to give 6 numbers. If we give 6 numbers, this will give us, this model will give us the output, right? Let us take the numbers as 52. The first one was age 1, okay, and this is 30 and 1 0 and 3. Okay, if we execute this, okay, so the medical charges are 10,951. Okay, so see, we had how many independent variables? Age, sex, BMI, children, smoker or region, right? So we gave this 6 values and we got the charges. So we gave 6 values and we got this many. This is the charge we got. All right, I hope this is clear. Let us go ahead and find mean squared error of this. So for that we need to import math. So import math, and from sklearn will import metrics. Okay, from metrics also will import mean squared error. Okay, we have studied about mean squared error and root mean squared error in the previous video. Okay, so mean squared error, let that be, okay, I'll just copy this, mean squared error. Okay, mean squared error of y underscore test comma y underscore predict. All right, but we need root mean squared error. So let us write root mean squared error as RMSE, and math.sqrt will give us mean squared. Math.sqrt of MSE, mean squared error, will give us root mean squared error. Okay, let us go ahead and print this RMSE also. So it is 5,643. Okay, our aim should be to get this number, to make this number very small. Okay, this RMSE should be minimum. That should be our aim. All right, so we got a value of 5,643. See, our charges y values were in thousands, right? 10,000, 50,000, 60,000, right? Isn't it? That's why we got RMSE in 1000. So don't think that this is a very big number. Compared to the charges, this is actually a smaller number, right? Square R2 score. Let us go ahead and find R2 score. Okay, so from sklearn, okay, metrics, we need to import R2 underscore score. Okay, so this R2 underscore score will be y underscore test and y underscore predict. So 79.98, almost 80%, right? So our model is giving 80% accuracy. All right, so this was it. Thank you so much for watching the video.